So we're doing right triangle trigonometry, right triangle, draw triangle, trigonometry. And with this, we drew a right triangle. And I'm going to call this theta. And for theta, we had some characteristics of theta. For instance, we would say this is the opposite side of theta. This is the adjacent side to theta. And we have hypotenuse. So knowing the three sides of this triangle, we can then lay out our sine, cosine, tangent. Sine of theta is the opposite side divided by the hypotenuse. It's what we call a ratio. So that's why we call these trigonometric ratios, because you're just comparing two sides. You pick any two sides, and we have a sine, cosine, tangent to speak for those two sides. We said cosine theta was adjacent over hypotenuse, and we have tangent of theta was opposite over adjacent. Then we could flip those over, talk about the reciprocal, was cosecant of theta is hypotenuse over opposite, and secant of theta was hypotenuse over adjacent, and cotangent of theta was adjacent over opposite. So you could dice roll this, and pick any two sets, and we will have a ratio for those two sets. Sine, cosine, tangent, or cosecant, secant, cotangent. And this is going to be important for us because we're going to have to make a choice later which one to use. So hopefully when you guys are going through the work, it made sense which one you were going to copy. And a lot of people were making simple mistakes. Like if I wrote theta is, call this a 3, 4, 5 triangle. If I ask you guys for the sine of theta, some people were writing 5 over 3. It's 5 over 4. But remember, it's the opposite over hypotenuse. So it's actually the wrong order. It's 4 over 5. Sometimes we have square roots, which mess us up. And people were having problems with square roots. So if I write 5, 6, that's 36 plus 25 is 50, 61. So square root of 61. If I ask you for the sine of theta, where theta is in this corner, this will be opposite over hypotenuse. And we spent a lot of time last time just showing you guys there's a fast way of fixing this. We can just write the square root on the top and double check if you can reduce anymore. A quick flash, if I say cosecant of theta, it's just the reciprocal, which is just square root of 61 hypotenuse over opposite. Some people had problems when you had a square root with multiple numbers in it. So this would be sine of theta would be 4 over 3 square root of 5, because that's my opposite and my hypotenuse. Opposite hypotenuse. And we said the fast way of writing this would be 4, put the square root on top, and then just write it without the square root. To go the long way, 4 over 3 square root of 5 is square root of 5 on top, square root of 5 on bottom, and the square root of 5 goes on top, and these clear out, leaving me no square root. And afterwards, you just have to make sure we simplify. 4 square root of 5 over 15. And I can't reduce. So a lot of people got IXL mistakes by just forgetting to reduce. So when you read the direction, it keeps saying simplify at the end. So we're going to first start off with special angles for our trigonometric ratios. So we mentioned before, we're going to look at the 30, 45, 90 angles. Those are, and also 60. 30, 45, 90, 60. Okay, or 60, 90. Let me erase that. 60 and then 90. So you guys are going to have to know these 4 major angles. Now, I want to talk about the origin of these 4 different angles. So here's my first triangle, and we talked about it before very quickly. We said this was a 30, 60, 90 triangle. Just for you guys to verify, doesn't 30 plus 60 become 90? And 90 plus the right angle is 180. Okay, just to verify that. Now, the sides we mentioned before is if this was 1, 2, square root of 3. Now, I'm going to show you guys the origin of this triangle. I'm going to draw instead, in geometry, you learned about a triangle which was called an equilateral triangle. Equilateral, where all three sides were exactly the same. All three sides were exactly the same. So if all three sides were exactly the same, 180 divided by 3 would give me, each angle would be 60 degrees. 60, 60, 60. And to make this easy, I'm going to call each of these sides the length of 2, 2, and 2. Now, I would like to ask you guys, how could I make this triangle into this triangle? How can I make this big triangle into this 30, 60, 90 triangle? And some of you guys might be like, oh, if I cut this in half, exactly in half, this would lead my inside angle now to become 30, because isn't 60 divided by 30? No, 60 divided by 2, 30. And since I'm cutting a perpendicular bisector here, this is going to be 90 degrees. So that's how we end up from a 60, 60, 60 to become a 30, 60, 90. Also, didn't we say this whole length was 2? And since I'm cutting it in half, that 2 now becomes a 1. So what we realize is that if my base is 2, I cut in half, we actually end up with a 30, 60, 90 triangle, where the short side will always be half of that of the hypotenuse. It will always be half of the hypotenuse. Now let me draw you a bigger triangle here. So let's see if it works out the same way. If I draw a bigger triangle, and I say this is 6, 6, wait, I should do that. 8, 8, and 8. And since it's equilateral, we can say each of these angles are 60. And if I want to cut this in half to make a point, that will lead us with a right angle. So let's look at this triangle here now. We have, this used to be 8. Now this is now 4, which is always half or double, depending which way you're going, of my hypotenuse. And the third side will always be square root of 3. See how this square root of 3 here? Let's take our time. Pythagorean theorem. 4 squared plus b squared, let's call this b here, is equal to 8 squared. That's my Pythagorean. 4 squared is 16 plus b squared is equal to 64. Subtract it, b squared is equal to 64 minus 16. It's going to be 48. And the square root of 48. So this is a trick that I know, but I'm going to go ahead and write it out. Divide by 2, divide by 2, divide by 2, divide by 2, left over 3. I have a 2, 2, and a 3. That's 4 square root of 3. Our b side is going to be 4 square root of 3. So if we go back for a moment and we look at what we wrote over here, if I start off with 1, we always, always, always double to become the hypotenuse. So if I start off with 4, we double to become 8. Always true. From the short side, okay, this is my short side. We always times square root of 3. That's 1 square root of 3 to get to my long side. Times square root of 3, get to my long side. So for this special triangle, we're going to draw this idea. If this is, call this A, the hypotenuse will always double, become 2A. And the sorry, let me write this as 30, 60, 90. This only works for 30, 60, 90 triangles. This will be a square root of 3, no matter how you see this. Always going to be true. If I give you the triangle, 30, 60, 90. Now, 30 will always be the skinny side. Remember, 30 is a small angle, while 60 is a fat angle. So 60 will always be the chubby side, and 30 will be the skinny side. I sometimes think of it this way, where this is like a small head and like a big belly. Right? See, right? Right? It's a big belly. So he has a fat belly with a tiny little head. America. If I say this is 10, automatically we know the hypotenuse side will always be double, and the long side, see, you have the long skinny side, that's always going to be square root of 3. That. Just one more example. I'm going to spin this around. 60, 30, 90. I'm going to this time give you guys the hypotenuse. This side is going to be 100. Well, how is you can rotate the screen if you want, but how is the hypotenuse related to the short side? How do I know it's a short side? Remember, that's the 60 side. This guy is, look, oops. He's a fat dude, right? His big belly. He's sleeping. A sleeping giant. And then that's going to be 50 because it's going to be half. Automatically, no math needed. This is the ratio for this triangle all the time. And the long side is 50 square root of 3. Always go back or start on the short side. If you don't have it, go back to it. So one of our special triangles gives us actually 2 of our angles already. It gives us not only our 30-degree angle, but our 60-degree angle. So we're going to do this right now. So how does this apply to what we've learned before already? So I'm going to go ahead and draw you in a circle. I'm going to draw a 30-degree angle here. Everyone okay with 30 degree? And it's always going to be a right triangle. Give me 1 second, please. So our goal is to get this back into the unit circle because we're going to see something kind of cool, that these 30-degree triangles appear often. So if I have a 30-degree triangle here, we automatically know that this is 1, 2, square root of 3. And we automatically know 1, 2, square root of 3. And this is for 30 degrees. But if I give you a 150-degree angle, that angle goes all the way around, almost touching 180, but we're short by how many degrees? We're short by 30 degrees. So it turns out 150 degrees gives you a 30-degree triangle. And we can say this is 1, 2, square root of 3. But we have to be careful here because we're in quadrant 2, which is negative, the x or the y. In quadrant 2 is x or y negative. Remember, we went left and up, left and up.
X is negative.
X is negative, thank you. And that is actually a big, like, I'm screwed type of answer. You have to put a negative because we went to the left here. But the sides are still 1, 2, square root of 3. And then so make sure you keep this someplace in your notes because we're going to come back in our calculators to prove that this is true. Next one. The angle is 210. 210 degrees would take us past 180 a little bit more. 210 degrees would be quadrant 3, but this would still be 30 degrees, which gives us a 30, 60, 90 triangle. Remember, the short side is 1, hypotenuse is 2, and the long side is square root of 3. In this case, the sides are left and down. Oops, I hate it when this happens. Are left and down. So we went left, and we also went down. So they're both going to be negative here. And then the last one in quadrant 4, this is going to be 300 and what? What do you think? We're 30 degrees short of 360. That's going to be 330 degrees. At 330 degrees, we are going to the right and then down. So x is positive, y is negative. The short side is the side opposite of the small angle. 2 square root of 3. And in this case, we have to remember that the 1, since it's going down, is going to be a negative. So when we're given angles, especially 30-degree angles, we can look on it on the unit circle, and we can tell what the sine and cosine tangent are going to be. So let's go ahead and write the sign for these problems now. The sine for 30 degrees, oops, that's not 30 degrees. Let's go back here. Sine of 30 degrees is going to be opposite, which is positive 1, over hypotenuse. Because 30 degrees is my reference angle here, opposite is my 1. Opposite over hypotenuse, which is now a 2. Go ahead and take a look for the next one. 150 degrees, quadrant 2. It's 150. Opposite of 30 degrees is still going to be 1, positive 1, over 2. In my quadrant 3, sine of 210 degrees, hey, I'm just copying pieces of the triangle. That's going to be negative 1 over positive 2. And my last one, sine of 330 degrees. Okay, my opposite, everyone see this is opposite on the opposite of 30 degrees? The angle in the reference, the corner angle? That's going to be negative 1 over 2. So bringing back what we had talked about before, we had mentioned that if stuff is in quadrant 1, all the x values are positive and the y values are also positive. Remember? And we said this is a cosine value and a sine value. And sine is positive in quadrant 1. Okay? You don't need to memorize this, but this is something that you will eventually start to realize. In quadrant 2, if I write numbers in quadrant 2, aren't x values negative and y values still positive? That's why sine is still positive here. But in quadrant 3, x's are negative, so our y values are both negative. So we said this is cosine and sine. So sine is negative. And then one more. In quadrant 4, we said x's are positive. We went to the right, but y's are always going to be negative in quadrant 4. And we see that the sine is negative here. So for these types of angles, and we're trying to figure out the sine, cosine, tangent, we have to do two things. First, we have to make sure the fraction is correct. And that is often done by just drawing the triangle on these basic angles, 30, 60, 90, 45. Okay. The second thing we have to make sure is we get always right is the sides. Sorry, not side, the sine, same word, sine. We want to make sure the sine. So 1, make sure the sides are correct. And 2, make sure the sign is right, is positive or negative. Now, there's actually a super quick way to tell if something will be positive or negative. Sure, you can draw it out. You can think about it. And some people are very good at this. And some people need help. So here is a quick way, a quick reference to tell us something is positive and negative. Okay? So it's going to be all students take calculus. Okay? All students take calculus. This refers to sine is going to be positive. Cosine is positive. And tangent will be positive. They will all be positive in quadrant 1. Everybody's positive. If you see an angle in quadrant 1, angles between 0 and 90, they will always be positive. In quadrant 2, look, do you see how this is S? What do you think S stands for? Sine, cosine, or tangent. S stands for sine. So sine is positive, but everyone else is negative. So cosine is going to the left. Tangent is going to be a positive divided by negative. So we're still going to be negative. In quadrant number 3, well, T stands for tangent. That means everyone is negative except for tangent. It's automatically going to be true. And we can see that. If you look up here, in quadrant 1, both x's and y's, sine and cosine, are both positive. In quadrant 2, cosine is negative, but sine, which stands for S here, all students take calculus, stays positive. See, this is still positive here. In quadrant number 3, both x's and y's are both negative. So both cosine and sine are negative. But tangent would be a negative divided by negative, would always become a positive. And cosine is the last one here in quadrant 4. So sine is negative because we went down. Cosine is positive, we went to the right. And tangent is going to be also negative. So just by knowing which quadrant you're in, where will the angle fall, you can know if you got the angle right or not. Now, if you guys have a scientific calculator, I want to show you guys can take that out, or you can use your cell phones. That would also work. So I want you guys to notice something right now. First things first, in your scientific calculator, you want to make sure that you see DEG. Maybe it's a little D on top, and that refers to degrees. If I change my calculator to radians, see, it turns to a RAD, or an R. So depending on your calculator, you want to make sure you're in the right mode. It's like speaking English or Chinese, okay? You have to know which language we're in. And radians is in pi, and degrees is in the 180. So for this example here, let's give our angle 30 degrees. And make sure I'm going to be in degrees. Make sure you are in degrees here. If you can take out a scientific calculator, we're going to be using it in just a little bit. But you guys can follow along. If I write 30 degrees, and I hit sine, oops, sine of 30 degrees, oops, sorry, 30 degrees, hit sine, whoops, wrong one. 30 degrees, hit sine, there we go. That's going to be a positive number. We said 150 degrees, hit sine. This is also a positive ratio. 0.5 is another way of saying 1/2. How about let's do 210. 210, let's go back really quick. 210 here, that's going to be negative 1/2, okay? Negative 1/2. So sine of 210. Oh, what happened here? I need to clear it, I think. 30, whoops. 210, sine it, negative 1/2, which is exactly what we got over here without a calculator. Last one, angle 330 degrees. 330, sine, negative 1/2, which is exactly what we were hoping for in our answer here. So right now the current goal is to find the sine, cosine, tangent of angles, okay, without using a calculator. Now, if I want to go back here, and I want to say, let's look at quadrant number 1, since we have space here. If I write let's do the cosine of 30 degrees. Cosine is adjacent over hypotenuse, okay? Square root of 3/2. Automatically, if I can draw the triangle, I can tell you the sides in seconds. In seconds. If I can draw the triangle, I can tell you what the sides are in seconds. If I ask you, what's the tangent of this triangle? 30 degrees. Since we have 30 degrees already drawn, that's going to be 1 over square root of 3, because it's the opposite over adjacent. Opposite over adjacent, which can be rewritten as square root of 3 over 2. Now let's double check to see if the calculator gives us these same answers. Cosine of 30. First, I want to make sure you guys know what square root of 3 over 2 is. Square root of 3 over 2 is 0.86. Everyone keep that in your head. 0.86. Square root of 3 divided by 2 is 0.86. So what is the cosine of 30? It's another way of saying is 0.86 with change. So let's see if our calculator gave us the same exact answer. 30 degrees cosine, oops, darn it. 30 degrees cosine is 0.86. My next one was, okay, tangent of 30 is square root of 3 over 2. Whoops. Square root of 3 over 3. I'm sorry. Can you guys change this? Make sure you write square root of 3 over 3. Square root of 3 over 3, okay? On the calculator, just to double check, square root of 3 divided by 3 is 0.57. I'm going to write 0.57 here. 0.57, just so that we have this. Now, what is the tangent of 30? 0.57, exact same answer. Okay, so this might be, Mr. Cole, this is a waste of time. We have a calculator. Well, I want you guys to see this over here. Let's look at quadrant 3. Given that we know this triangle in quadrant 3, can you guys look at the triangle in quadrant 3? You know what? Let's go ahead and write a new one. If I ask you guys for the angle 330 degrees, quadrant 3, 30 degrees, hey, I know this triangle. It's a 30, 60, 90 triangle. 30, this must be 60 and 90. That's 1, 2, square root of 3. Which of these sides are negative? Going right and down. Going to the right is negative. The sine of 330 degrees is opposite, which is negative 1, and hypotenuse, which is 2. My cosine of 330 degrees is square root of 3 over 2. My tangent of 330 is negative 1 over square root of 3, which is written as negative square root of 3 over 3. Now the cool part is we can write this as negative 0.5, positive 0.86, and negative 0.57. Again, these are numbers I'm just copying from these answers that we previously had over here. Changing those numbers to decimal. So again, how did I come up with those numbers? I drew a simple triangle and then I have the ratios. To prove that these are the same answers on the calculator, the 330 cosine is the positive 0.86. Positive 0.86, like we said. 330, and let's take the tangent of it. Whoops, I need to clear it. 330 tangent is negative 0.57. Negative 0.57. How about something simple like sine? 330 sine negative 0.5. So our goal right now is to be able to come up with our 30, 60, 90 degree triangles without using a calculator. That's really what the goal is. So here we go. Let's do our next angle real quick, 60 degrees. Now, we did 30. Now, here is 60 degrees. And you tell me, does this look like a triangle that I just drew? Would 30 and 60 pretty much be the same triangle? Short side is next to the fat tummy, 2 square root of 3. If I asked you to draw a 60-degree triangle, wouldn't that be stalling tall and proud? Because 60 is a bigger angle than 30. 30 is like a worm on the floor. Look, you're just slithering. It's on the floor. That's a low angle. So 60 should be tall and proud. And then we can say the sides are 1, 2, square root of 3 automatically. Any of these negatives in quadrant 1. What is the sine of 60 degrees now? 60 degrees is opposite square root of 3 over 2. What's the cosine of 60 degrees? Cosine is 1 over 2. Adjacent over hypotenuse. This is opposite over here. So we're just copying the three sides. Tangent is of 60 is square root of 3 over 1. And we're done. So the cool thing is that now any angle with a reference angle of 60, and how do you get a reference angle of 60? There's actually a trick. Can you divide that angle that you're on by 60? So let me show you them all on the unit circle. Can I divide 60 by 60? Yes, this is a 60-degree reference angle. 120. Can I divide 120 by 60? Yes, this is a 60-degree angle. Can I divide 180 by 60? Yes, but the problem is that's not going to leave us a triangle. We'll talk about that a little bit later. 240. Can I divide 240? No, wait, it's 240. Yeah, 240, yes. Can I divide 240 by 60? Yes, I can. Can I divide 300 by 60? Yes, I can. Now what happens, it gives us all the other possible triangles for 60. So we have a triangle here, triangle here. Just so you guys can see the different triangles. Now, what's so good about knowing it's a 60-degree triangle is because we know now that the sides are going to be 1, 2, square root of 3. 1, 2, square root of 3. 1, 2, square root of 3. Let's go back and make sure we got our negatives correct. Is 3 negative to you? Does that look negative to you? We went up. No, not negative. Look at the 1. Yes, the 1 is a negative because we went left. How about the negative? How about the 3 here? Square root of 3 is negative. Yes, because we went down. Over here on the right side, you tell me which of these would be negative, the 1 or the square root of 3? Which of these? 1 to the right, this is 1 to the right, or going down by square root of 3? Only one of these is going to be negative, and that's going to be square root of 3. So if I ask you, what is the sine of 60 degrees? Hey, I know 60-degree triangles. Those are easy ones. 60 degrees would be opposite 1, 2, square root of 3. That would be square root of 3 over 2, automatically. So this is something that we have to work to be able to do. You will be accountable for all the basic 30, 60, 90 triangles, and you will have to know what they are pretty quickly. What is the sine of 240 degrees? 240 is divisible by 30, but it's also be divisible by 60. Okay, it's a 60 degree. I'll take 60. So this is how fast I would draw it. 240 is bigger than 180 with a reference angle of 60. Hey, I know these sides. 1, 2, square root of 3. And square root of 3 is negative because we went down. Also, 1 is negative because we went to the left. So sine is opposite, hypotenuse, and adjacent. Let's go into opposite is negative square root of 3 over hypotenuse of 2. Okay, let me pause for a moment. So we got one more what's one more type of triangle to do, and then we'll actually two more actually, and then we'll call it. So, well, then I'll show you how to do the calculator one. So let's do 45-degree triangles. 45 degrees are born from a square. I give you a square. Isn't a square 90, 90, 90, 90? And if I cut a square in half, each of those side angles become 45. Oops. 45, 45, 90. Okay, knowing that, that means the size is 1, 1, and the Pythagorean theorem says this is square root of 2. So let me draw that for you again one more time. For 45-degree triangles, this is always the case. If you have a 45-degree angle in a right triangle, 1, 1, square root of 2. Draw this again. What if the side was 3? 3, 3, 3, square root of 2. What if the side was 10? 10, 10, 10, square root of 2. Now, this does look like a 30, 60, 90 triangle, which is 1, 2, square root of 3. Now, here is my hint. Please take my hint, okay? My hint is this. How do you know when it's square root of 2 versus square root of 3? Hey, isn't it 45, 45, two the same angles? So two of the same angles, two the same sides, always square root of 2. But a 30, 60, 90 triangle has 3 different angles, 3 different sides. So it's always going to be square root of 3 because they're all different. Again, 45, 45 is having 2 of the same sides and angles. So that's why you get the square root of 2. But 30, 60, 90, all 3 sides are different. That's why we're going to end up with square root of 3. So let's go ahead and say 45 degrees. So we draw a triangle 45, and we say it's a 1, 1, square root of 2. So the sine in quadrant 1 of 45 degrees is 1 over square root of 2, because it's opposite over hypotenuse for sine. Stay away from sin. Rewriting this, square root of 2 on top over our free 2. Let me do that again. 1 over square root of 2. We multiply square root of 2 on the bottom and the top. So square root of 2 over square root of 4, which is back to a freedom 2. Now, this is helpful because now I'm going to give you guys something quadrant 3. 180 plus 45 is 225. So if you ever see 225, this is a 45-degree angle. Yes, it's 225 from 0. That is right. That's 225. But for our sake, to make this easier on us, we see this as a 45-degree triangle because the reference angle is only 45 degrees over, which gives us our 45, 45, 90 triangle. That means we know the 3 sides. 1, 1, square root of 2. Okay, 1, 1, square root of 2 is my 45-degree triangle. Now last one, they're both negative because we went to the left and we also went down. Now knowing this, the sine of 225 is going to be negative 1 over square root of 2. We don't like square roots on bottom, so we write it on top, square root of 2 over 2. So in the homework today, you guys are going to do 1 first. Tell me what the reference angle would be. Then 2, you guys are going to go ahead and use your calculators, and we're going to work backwards to figure out using a calculator to help you guys solve for this. Okay. Okay, so here's the last triangle. Here's our 90-degree triangles. And the 90-degree triangles, oops, oh no, I did that. Triangles. So here's the purpose. If I say sine of an angle, you know that's always going to be opposite over hypotenuse. Now, if you could only draw the triangle, the opposite and the hypotenuse would be really easy and clear to find. Again, if you could draw the triangle, we'd be in great shape. But 90-degree triangles don't exist. This is a 90-degree angle for you guys. Now, can we draw a triangle with that? No. So I'm going to cheat. I want to show you something. 90 degrees looks like this, right? I'm going to force a fake triangle to come out. Okay, so watch. I'm going to pull this to the right. I want to make a triangle like that. Okay, take a look what I did. I pulled it to the right in quadrant 1, and I drew a triangle out of it. It's almost like opening the curtains. You pull the curtains open. Okay, and the reason why is if you stick your arm straight up, is there really an x value? Okay, if you stick your arm straight up, is there really an x value? There isn't. So here is my cheap trick. Because we don't have an x value, that's a 0, 1, 1 triangle. Take a look at, again, what we did here. First things first, I said at 90 degrees, I'm gonna draw the same thing over to the right. 90 degrees is up here. That's not a triangle. I can't draw a triangle with 90 degrees, so we fake it. I'm gonna pull out. I'm gonna pull out a fake side, and then I'm gonna draw a triangle there. My follow-up question is, hey, if I was going straight up, what don't we have? Do we not have an x or a y value? No x or no y. Since it's straight up, we have no x. Oops. We have no x value, but we do have going up, a positive y value, positive 1. Now here is the cool part. What is the sine of this triangle, 90 degrees? What is the opposite over hypotenuse? What is the cosine of 90 degrees? Well, that's the adjacent over hypotenuse. What is the tangent of 90 degrees? That is opposite over adjacent. Now this is equal to 1, this is equal to 0, and this is undefined. There is no tangent at 90 degrees. Now going back to our unit circle, take a look here, please. If this was a circle with a radius of 1, wouldn't the x value be 0 and y value be positive 1? Again, a circle with a radius 1. The x value would be 0 and the y value would be 1. Isn't this my cosine value and my sine value? Which is my answers here. You could memorize it, and that's 100% great. A lot of people will just straight memorize it, where my cosine is 0 and my sine is 1. But sometimes people forget. I like drawing the triangles. Let me show you guys another one. What is the sine of 180 degrees? You could say, okay, sine is y, sine is y, sine is y. 180 degrees is on the floor. Hey, what is your y value of something on the floor? That's 0. But if you don't know, let's draw a triangle here. So I'm gonna draw a triangle like we did before. I'm gonna pull it up. Now, I wanna show you guys what visually this looks like. So here is my angle lying dead on the floor, right? And I'm gonna tilt it up like that. I'm gonna drag it up. I'm gonna pull open that door. I'm gonna lift it off the floor. See, I'm lifting it off the floor. But is there really an angle if something is lying dead on the floor? No, that's a 0, 1, 1 triangle. So 90 degrees are 0, 1, 1 triangles because one of the sides doesn't actually exist. Are any of these sides negatives? 0, 1, or hypotenuse 1? We went to the left, that's a negative 1 here. Sine is opposite over hypotenuse. That's 0 over 1, which is the 0 that we claim to be. What's the sine? Whoops, not sine. What's the cosine of 180 degrees? This is going to be adjacent over hypotenuse. Looking at this problem, adjacent is negative 1 over 1, which is negative 1. If this was a unit circle, this would be the point -1, comma 1, so comma 0, where the sine would be 0 and the cosine would be -1. Okay. So it works like this for all the triangles. Let me finish up one more triangle for you guys. And that's the 270. So we draw the 270 this way. Whoops. Yeah, that's fine. And where the x value is 0, because there is no x value going straight down, and the y value is -1. 0, 1, 1 triangle, but going straight down for 270. And 360 over here, you could draw it up or down, doesn't matter, because the y value is 0, 1, 1. And this could also be 360 or 0. Okay, let me jump to your homework real quick. Let me jump to M8. So this problem is going to ask you to say, okay, what is the secant of 30? Okay, secant of 30, you should just know it. Well, here's a fast way. This is how fast I want you guys to be able to do it. Draw a 30-degree triangle. Look how accurate that is. Write 30 in the corner, please. Have we seen a 30, 60, 90 triangle before? Yes. 1, 2, square root of 3. How do I do that? The short side is always 1. Hypotenuse is always double in a 30, 60, 90 triangle. And the long side is square root of 3. Secant of 30 degrees is hypotenuse over adjacent. Copy hypotenuse, copy adjacent. That's it. Rewrite it. 2 square root of 3 over 3. Go back. Fraction 2 square root 3 over 3. Submit. Okay, tangent 45. Okay, got it. Tangent 45. Tangent 45. Draw a 45-degree triangle. That's right here. That's 45 degrees. Hey, I've seen a 45-degree triangle before. That's 1, 1, square root of 2. All positive in quadrant 1. Tangent is opposite over adjacent. Opposite is 1 over 1. Opposite and adjacent. 1 over 1. Answer is 1 over 1 is 1. Cotangent of 30. Oh my goodness. Didn't we just draw 30 degrees? Let's just go back and look at that triangle. 30 degrees of cotangent. Cotangent is adjacent over opposite. Adjacent is square root of 3. Opposite is 1. Square root of 3 is my answer. Square root of 3 over 1 is square root of 3. Oh, pi over 6. Oh my gosh, pi over 6. What is pi over 6? Pi over 6 is a 30-degree angle. If you don't believe me, pi over 6, if I multiply pi by 180 over pi, what's 18 divided by 6? That is 30 out of 0. 30 degrees. Didn't we draw the secant of 30 degrees already? Secant of 30 degrees. We just did it. 2 square, oh, I need to write fraction first. Oops. Fraction 2 square root 3 over 3. Okay, my smart code is already 36. That's not bad. Cotangent of pi over 4. Hey, we just drew pi over 4. That's 45 degrees. Cotangent is 1 over 1. Cotangent of pi over 3. Uh-oh, pi over 3. What's pi over 3? Pi over 3 is the same as 180 divided by 3. This is another fast way of doing it, where we just swap it. That's 60 degrees. Let's draw a 60-degree angle. Sides 1, 2, square root of 3. How'd you do that so fast, Mr. Ko? Because 1 is always next to the 60. And the cotangent of that is adjacent over opposite, 1 over square root of 3. We're not allowed to just leave the square root of 3 on the bottom, so we rewrite it. Square root of 3 over 3. I'm almost there, okay?